Okay, so for example B, we've got f of x equals the square root of x minus 3. Well, we may not know what that looks like, and being that we're in IB and part of your final exam is going to be with the calculator, we're now going to use the TI-84 to see what this actually looks like. So we're going to turn this on. The on button's down here at the bottom. And we're going to go to y equals, and we're going to put in the values, or put in the function, and it actually, I believe it has a square root function. Square root, and I'll put this in brackets, x minus 3, and the x is this button here beside the alpha where it says xt theta n. That's the button that we would use for to give a variable, x minus, and for the x, and then we're going to have minus. Now the minus is here. This is a negative value right here down below the 3. That's a negative, so if you have a negative at the beginning of your expression, this is the one you would hit. If you have a minus, you hit this one here. So we're going to hit the minus, and then 3, and enter. Okay, so now that's registered, and now we're just going to hit graph, and we'll take a look at see what that looks like. Okay, great. So that is the graph of the function. We see that it starts horizontally along the x-axis. It starts at x equals 3, and vertically it starts at y equals 0, and then it just goes on forever. Now what we could do is we can hit trace, and we can trace along the curve if I just hit the right arrow key. Okay, so it was, the cursor started at 0, 0, and there was no y value there. So when I hit to the right, when it got up to 3 eventually, then the cursor appeared, and now it's showing the y values. Okay, so I can go along here. I don't know if I will be able to scroll along. Okay, so the curve scrolls with it. So I can just keep scrolling here and scrolling. So it's going to go on for a long, long way. Well, forever, actually. So for the domain now, the domain is the set of x values, such that, now in this case we know that x starts at 3, and so we know it's starting at 3, so x is greater than or equal to 3, and x is an element of all real numbers. Okay, so it's equal to 3 because it starts right at 3 there. And the range is the set of all y values such that y is greater than or equal to 0. And of course y is also a member of the real number system. And if we then take a look at this next graph, so I'm going to go back into y equals. I'm going to clear y1 because I don't need that anymore. And now I'm going to say, well, let's see what this reciprocal of this is. So this is the reciprocal of this graph. Let's take a look at what that looks like. So I'm going to say 1, you know what 1 is 1, and then I'm going to go divided by, and then I'm going to put this in brackets again. Put the square root, and I'll do x minus 3 again, close the brackets, enter, and I'll graph that this time, and we see that's interesting. It just kind of starts in the middle of nowhere here. Let's trace. Let's go back here and see what's happening. So it looks like x, where it starts on the x in the horizontal axis, is around 3. Now I'm going to zoom in a bit too. Zoom in, zoom 2, and enter. So I've really zoomed in far there, and I hit trace again. So the cursor here is at 3.19 and negative, 2.28 is positive. And if I go up I'm going to see that we're approaching 3. Once I get less than 3 at 2.97, then y ceases to exist. Okay, because that means that the graph actually has not occurred there yet. So it looks as though the y value is going to be around 6-ish. Now I could perhaps zoom in again a little closer. And now we're getting really close. I'm going to trace a little bit further. Oh, so it's actually, so 3, when x is 3, y is actually 13.7. So it's getting really close there. Okay, so let's see, the domain is all values of x such that x is greater than. Now, we have to actually take a look at this itself. Now, from this graph, we saw that x could not be less than 3, which means that x cannot, from this graph we could see that x could not be less than 3. We can take the square root of 0, that's no problem, but we cannot take the square root of a negative value. So let's say -1, for example. Okay, so that does not exist. We cannot do that. So that's why x has to be greater than 3 in this case. So, or it can be equal to 3 because of it can be a square root of 0, that's no problem. Now, in the denominator of a function, we cannot have 0. So the square root of x minus 3 cannot equal 0. Therefore, x cannot equal 3. So x has to be greater than 3. Okay, so that's why, sort of taking into account this first example and then the fact that the denominator cannot equal 0 or else the function will not exist, x has to be greater than 3. Again, x is an element of all real numbers. And then for the range, y, now here's an interesting thing. When we have this value of 3, this x equals 3, notice that the y is at 13.7. Now what if I were to zoom in a little bit closer? Zoom in closer still. Now the line's looking really, really vertical. I'm going to trace again. Continue going to smaller values of 3. So I got 3.00199. The y is up to 22. Now I don't know if, okay, at this accuracy I can't go closer to 3 unless I zoom in further, which I will. Okay, so I'm going to zoom in further, I'm going to trace, and I'm going to go a little bit closer to 3, 3.0116, 3.0003324. See that the y value is climbing up to 54.84. What's actually happening there is the graph is approaching what's called a vertical asymptote. And a vertical asymptote, which we're going to get into later, but a vertical asymptote occurs when at an x value that would make this undefined, make the denominator equal to 0. So the y values can continue on. The graph actually continues going up forever and ever beside that vertical asymptote. So I'm just going to do a quick sketch of what this is actually looking like. We saw a little bit of the graph. It's just a very rough sketch here. So at 3, x equals 3, there's going to be that vertical asymptote, and the graph is actually going like this. So it's approaching the x-axis, so getting closer and closer to 0, but it's also approaching the vertical asymptote, going further and further vertically. So all that means is that y is a set of values such that y is greater than 0. And y is an element of all real numbers. Okay, it's greater than 0 because it's approaching the x-axis. And I'll show you that also. I'm going to zoom out maybe a couple times to get back to where we had a better view of the curve itself. So I keep zooming out. And we see that now the graph is has that little L shape. So that means that the graph is approaching the x-axis but not actually getting to it. So it's greater than 0, and we see that because the graph is going up vertically forever in this way, just like it's in the graph there, then it's going to be greater than 0 and just continues up for there. Okay, so that's a little introduction to the TI-84 to help us find the domain and range here.